Hello viewers, and you're watching The Maths Geek. As you can see from my screen, today's video is all about the divisor function. Well, an introduction to the divisor function, one of the most important functions in number theory because it has a close relation to Riemann zeta function. And the mercenaries out there must have heard of the Riemann zeta function because it has a $1 million prize regarding a closely related problem, the Riemann hypothesis. But that's for another video. Now, let's go into the depth of the divisor function. Right, so I'm planning to make two videos on the divisor function, and this is the first one. The second one will be obtaining the formula for the divisor function. Introduction. The divisor function, denoted by d sub x of n, is defined to be the sum of the xth powers of all divisors of a number n. D sub x of n is equal to the sum of all beta which divide n of beta to the x. So it's the sum of the xth powers of all factors of a natural number n. We are going to examine this function at x equals 1 in the second part of this series. To obtain a formula for d sub 1 of n or d of n, we will have to introduce a function delta of n or the number of divisors function. Obtaining a formula for delta of n. Well, this is our main goal in this part of our series. Consider a number n equals a to the p times b to the q, where a, b, p, and q are all positive integers and a and b are primes. So basically, we've written out the prime factorization of any arbitrary number n in algebraic form. Number of factors of n denoted by delta of n is given as the intersection of these sets. So first you have 1, which is a number. It's trivial that 1 is a factor of every natural number. Then you have this string of numbers from a to the p, which of course have all the exponents a square, a cube, and so on till a to the p. It's clear that if you have a to the p as the highest exponent of a in your prime factorization, all the lower ones will also have to be factors. Similarly, you get all the b exponents from b to the first to b to the q, and now don't forget that you also have the numbers which can be formed as the product of these two powers. So you can have a times b square, a times b cube, and so on till a times b to the cube. That's your first set, and you can do this with all the factors of a, multiplying them with all the factors of p, and thus this set will contain p times q, which is pq numbers. So let's consolidate it all. Counting the numbers of elements in each set, we obtain delta of n equals 1 plus p plus q plus p times q, which is p plus 1 times q plus 1. Therefore, for an arbitrary n, a to the p times b to the q, delta of n is given by p plus 1 times q plus 1. Note, this formula can be extended based on the number of exponents. So if your number has 3 exponents, then it's 1 added to all the exponents and you multiply them together, right? So some demonstrations and then we'll end this video. Demonstrations. Let n equal 56. 56 equals 2 cubed times 7 to the first. Comparing it with a to the p times b to the q, p equals 3 and q equals 1. Therefore, number of factors or divisors is going to be p plus 1 times q plus 1, 4 times 2, which is 8. Sure enough, 56 does have 8 factors which are listed down here. Therefore, our formula works for n equals 56. Last demonstration. Let n equals 748. 748 equals 2 squared times 11 to the first times 17 to the first. Well, I chose this number because it has 3 exponents, just to give you an idea of how a formula would be if the number of exponents were greater than 2. Right. Comparing it with a to the p times b to the q times c to the r, we get p equals 2, that's your exponent of 2 here, and you get q equals r equals 1. These are your exponents of 11 and 17 respectively. Therefore, number of divisors of factors is p plus 1 times q plus 1 times r plus 1, which is 2 times 3, or 2 square times 3, 12. Factors of 748, sure enough, if you count them all listed here below, there are 12 factors of 748. Hence, the formula works for n equals 748. Don't worry, I haven't forgotten the primes. Note, delta of p equals 2, where p denotes a prime. Right, so we've generalized this result for primes too. Well, why is it simply 2? Because by definition of a prime number, the only factors of a prime number are supposed to be 1 and itself. And if you put this number into a formula, you surely will get 2. Thank you all for watching this video. Don't forget to like, subscribe and share. Well, in the next part, I will be obtaining a formula for sum of divisors of a number n from this video. So please be sure to watch this. Only then you will be able to understand what I will be doing in the next video. Thank you. Goodbye. This is Gauransh Kapoor from The Maths Geek signing off.